Okay. If we want to know why the chicken crossed the road, the old answer used to be, why did the chicken cross the road? What was it? Yeah. Behavior said, we don't know what the chicken is thinking. You can't even ask it because chickens don't talk. Right? We don't know if the chicken has a mind and if it has a plan, if it knows what it's up to. So we don't want to talk about what's in the animal's mind. Why did the rat cross the shock grid? We've got a grid here of wires, and on this side there's food, and on this side there's a rat. The rat tiptoes across the shock and eats the food. Somebody might say, why did the rat cross the shock? Because it was hungry. How do you know it was hungry? Because it crossed the shock to get to the other side. Must have been hungry. Well, how do you know what he was feeling, or whether rats feel anything, or whether they feel anything like what you feel when you think you're hungry? We have no idea what the rat is feeling or thinking. So let's get rid of all this. You know, there's a stalactite in the subconscious mind. We don't want to talk about the mind. We can't observe the mind. We certainly can't observe the subconscious mind, right? And we can't observe the brownies. So let's not have theories that are based on the brownies or the mind of an animal or the subconscious mind or that trees have feelings or any of these other things that we can't ever check. So things that aren't checkable, we're going to get rid of them. What can we observe? We can observe stimuli, like food. We put food here, put a rat here. Right? We can observe behavior. That's what the rat does. And so we're going to say, how did the stimuli, that's the things that were available, that the rat could see, smell, taste, touch, and feel. So how did what the rat could observe affect its behavior? And we're going to get rid of all this discussion of mind and mentalism. So this was a reaction to Wundt and to Freud and to other people that had talked about wanting to talk about psychology as if it has something to do with the mind. If we can't observe it, we can't get a science of it. We want to have a science. So the whole idea of behavior and behaviorism in the 1920s, this came in and dominated basically academic psychology, certainly in the United States. Two names associated with behaviorism are Ivan Pavlov, a Russian physiologist, and John Watson, an American psychologist. Watson wrote a book called Behaviorism, in which he talked about the virtues of having theories that actually make testable predictions. In other words, theories that actually say something, that you can actually use to do something. And the behaviorist said, you can't cure somebody by telling them there are brownies, or that their brownies are frangulated, or that they have a subconscious mind with a stalactite in it, and once they realize there's a stalactite, get rid of the stalactite and break the stalactite and then turn it upside down and do something with something in the subconscious world that nobody can observe. That'll cure them? Why should that cure anybody? That's like nuts. If you start telling people about the brownies, you got a mentally ill person, you're telling them there are brownies that make you do what you do. Oh, I can't help what I do, the brownies make me do it. You're making them sick. No wonder they're sick. And we'll see more precisely what their argument is. The behaviorist said, these people are causing other people damage. We want to build a science based on it. Now, part of the science comes not from a psychologist, but from a physiologist. Of course, this is in the early days of what comes to be called psychology. First psychologist was Wilhelm Wundt, 1879. He moved from Heidelberg to Leipzig, and they named him the first professor of psychology to do what he was going to do. I'll tell you more about his story later. So let's talk about Ivan Pavlov. He was a Russian physiologist. He won the 1904 Nobel Prize or his work with the gastric fistula. He wanted to unconfound, he wanted to do an experiment to unconfound variables that are normally confounded. So just as Funkst unconfounded what the facilitator saw and what the child saw, what the audience saw and what Kluger-Hans saw, but it's the same thing, right? He wanted to unnormally, the audience saw the same card as they showed to Kluger-Hans, or the facilitator saw the same information that was shown to the child. They did the experiment to unconfound them. What did Pavlov do? Well, he was interested in what produces gastric juices. What makes your juices flow? Food in the mouth or food in the stomach? Now, normally when an animal eats, the food that it gets in the mouth goes into the stomach. How could you get food in the stomach without it being in the mouth? So he wanted the animal to be able to eat without food in the stomach, and he wanted to have food in the stomach without the animal eating. Normally, food in the mouth, food in the stomach. No food in the mouth, no food in the stomach, right? So he wanted to separate those, and he did this by means of the gastric fistula. What he did is he did a surgery, cut open the throat of the dogs, and he led the throat to the outside, and the other end of the throat he led to the outside, so he now had two holes, and then he stuck in a glass tube so that if the dog ate, it would go through the tube and then back down and into the stomach. Or he could take the tube out and he could put food in directly into the stomach, or he could take the tube out and let the dog eat and it would just fall out the hole. So that way he could separate food in the mouth versus food in the stomach. I'm not very good at drawing a dog. All right, I'll make an attempt here. Right.
That's pretty good.
The wolf.
The wolf.
Yeah.
Maybe if the ears were bent, it would look more like a dog, right? Yeah. All right. Maybe it's a wolfhound. All right, so here's this hole, here's this hole, so that we've got and basically he's got a tube that he can put here, so what it eats goes through the tube into the stomach, or take the tube out, then what it eats would fall out the hole. He's got a cork in here, he can pull open the cork, put food into the stomach. We're still doing these studies. You'll know if you go to an experimental farm, I don't think we have a farm section on our campus, we don't have agriculture, but you go to a university like Texas A&M, it's a military and agricultural institute, or University of Illinois has a big school of agriculture there. You'll find the animals, you can smell them on the main campus there too. South farms, they call them, you can smell the pigs and the sheep. The sheep are there with little tubes in their stomach, sticking out, or with corks with ribbons with different colors attached. So he did the gastric fistula to find out how much of the gastric juices were being produced by food in the mouth versus food in the stomach. And he looked at to separate those amounts. But he discovered the following thing. So while he did this, he got the Nobel Prize for that work. But while doing this research, he discovered an unintended finding, which was this. The dogs are in their cages, doing nothing, no food anywhere. But when somebody comes and walks, the dogs could hear the steps. You guys heard the steps there? Most of you can hear. So when there was a sound of like that, the dogs started salivating. And if somebody came and turned on the lights, so they're in the lab in the dark, and the lab assistant comes, turns on the lights, the dogs start salivating. And if you show them the food dish that you're about to feed them, they start salivating. And he said, something else has happened. The dogs have learned something. So he's thinking about reflexes here. That was his term. And he thought about a learned reflex, that there's been some learning that's happened. Some learning has occurred. The dogs are learning to associate the sound of the footsteps and the lights And he began working on what comes to be known today as classical conditioning. So let's look at Pavlov's classical example of classical conditioning. Let's say we want to train a dog so that when we ring a bell, it salivates. Here's the current terminology. It's similar to Pavlov's terminology. So this is classical. Now, the sound of a bell, before conditioning, if you simply get a dog that has no experience with the bell, and you ring a bell, ding, dogs don't salivate. They maybe perk up their ears and they turn and they look at the bell, they look around, so they get what's known as an orienting response, but they don't salivate to a bell. And so the bell is called a conditioned stimulus. It's not conditioned to start with, but food, if you don't need to train a dog right away. If you take a dog without any special training and put food in its mouth, it salivates. So food is an unconditioned stimulus. It doesn't take any conditioning. So bell is a conditioned stimulus because it doesn't produce a response. But food is an unconditioned stimulus that produces an unconditioned response. Of salivation. Now, this is before conditioning basically. So let's label this as before conditioning. Then we do the conditioning. And how are we going to condition? Well, what you do is you ring the bell and present food to the dog. Ring the bell, food. So bell, food. We're pairing the conditioned stimulus and the unconditioned stimulus. I'm going to abbreviate the conditioned stimulus CS, and so from now on, you're going to have to just learn that CS stands for, well, there's a lot of dirty things it might stand for. Chicken something or other, or another type of chicken, a cock something or other. We're gonna call it a conditioned stimulus, and the unconditioned stimulus, we'll call it a US or a UCS or a US. Oops, US. And so I don't want you to think this is like the University of California at Santa Cruz, United States, or some other things here. This will be an unconditioned response, or a UCR, not University of California, Riverside. So I'll use these notations after this, all right? So before conditioning, we have a conditioned stimulus. Then what we're going to do is conditioning. And that consists of pairing the conditioned stimulus and the unconditioned stimulus. Ring the bell, feed the dog. Ring the bell, bell, food, bell, food, bell, food. And it's important that the bell precede or coincide with it. I'll say more about that in just a second. So bell and food in our example. And so after a number of trials, so these are trials, each of these is a trial. So after some number of trials, I'll say more about that, so that will be called the learning curve. How the behavior changes over time is called learning. And not every change of behavior in time is called learning. Some changes of behavior, like I knew a guy, first he had hair, and then he learned to become bald. As he got older, he got smarter and smarter and got balder and balder. Yeah, we don't call that bald. Or little kids learn how to be big. First they start off little, and they eat lots of food, and they learn to be big, No, we call that development. We don't call that. So some changes of behavior, that's called development. But these changes as a function of changes in the environment. These are called learning. So a change of behavior that's a result of change in the environment is called learning. So after a number of trials, what happens? Now you can present the CS, the bell, and what do you get? You get a conditioned response, CR. In other words, you get a response to the bell that wasn't there before. So the bell originally was a conditioned stimulus. It did not produce the conditioned response we're looking for. What's the conditioned stimulus in this case? The bell. What's the conditioned response in this case? Salivation. So the animal salivates in response to the bell. Because the bell has predicted food, and food generated salivation, so now the bell generates salivation. So the sound of the people coming to the door, people came to the door, then they fed the dog, right? So it predicted getting fed, turning on the lights. They turned on the lights and opened the cages, and they fed the dogs. They bring out the dish, the dog sees the dish, it salivates, because these things predicted getting fed. So that variable that predicts the unconditioned stimulus begins to take its place. Now, Pavlov used the term reflex. This was an unconditioned reflex instead of an unconditioned response. Now we don't necessarily call it a reflex. We just call it a response because we don't want to think that there's necessarily a neuronal connection, which Pavlov did. So instead of using terms like reflex, we're using the word response. Simply the behavior is exhibited. Everybody clear on this example? All right. So this is classical conditioning. Let me review a few of the terms of classical conditioning. So this is called a learning curve. We plot the number of drops of saliva in response to the conditioned stimulus only on trials. And this is the number, the dependent variable here, or what we're plotting on the ordinate is the number of drops of saliva. And so after one trial, ring the bell, feed the dog, and now we ring the bell by itself. After one trial, or after 0 trials, if you ring the bell, you don't get any saliva. After one trial, you get some. And after 2 trials, and so on, and anyway, let's give them more for this one so I can draw my curve. You get a curve that looks like that, so it goes up as a function of trials. It increases. This is called learning. And people have fit mathematical models to the learning curve. Some courses you'll learn how to use the mathematical models that have been proposed to describe learning curves. And then what you can do is stop presenting the food. That's called extinction. So we stop pairing the CS and the UCS. So I'm going to stop presenting the food now, but we just keep ringing the bell. So we ring the bell, see if the animal responds. And what happens is the response weakens. And so this is called an extinction curve. If we now take a break, so now we take a break, wait till tomorrow. I'll put a little kink in the graph down here, function of trials. Bring the dog back the next day, ring the bell. So as soon as we bring the dog back, it comes back. This is called spontaneous recovery. So the learned response returns in strength. It hasn't been completely extinguished, but it recovers. So there's a recovery of the response, and you can continue to extinguish it. All right, so that's known as spontaneous recovery. Let me talk about backward conditioning that I mentioned. The main thing to know about backward conditioning is that it doesn't work. So let me, can I erase this? All right. Here's time right here. Here's the bell. This is our conditioned stimulus. And here's our unconditioned stimulus. So notice the conditioned stimulus happens first and then the unconditioned stimulus. We can vary the time between these two. And it turns out that the maximum conditioning occurs when the conditioned stimulus is about 1/2 of a second before the unconditioned stimulus. So you get good conditioning if they're simultaneous, optimal conditioning if it's 1/2 a second earlier, less good if it's way earlier, but it doesn't work at all if it comes afterwards. So backward conditioning would be, so optimal is that the conditioned stimulus precedes the UCS by about 1/2 second. Backward conditioning is where the unconditioned stimulus occurs first, and then the conditioned stimulus, and it doesn't work. All right, any questions about that? Okay, that's it for today then.